All right, we're going to start, before we start elimination notes, we're going to start with the warm-up. And the first warm-up we did, this was 2 days ago. Actually, it was on Monday, so I guess it was 3 days ago. We solved by graphing. And I, just to refresh, showed you guys how to do it on your calculator. So we're going to do it that way. Okay, I strongly think if it comes to having a system, they're probably going to ask you to do substitution or today's lessons on elimination method. But graphing is also a way to see it. If I type this into my equation, y1, I'm going to make x minus 1. y2, I'm going to make negative 2x plus 5. Make sure that you use the negative sign down here and not the subtract key. It does make a difference. It will, and, okay, let me go try that again since I didn't type it on the right line. And negative 2x plus 5. In case I've changed my screen, I'm going to hit Zoom 6, which takes you to a standard window. Zoom 6 always takes you to a standard window. Do these two lines cross? Yes. Yes. So we're going to do what's called intersection. Didn't we have notes on that, and I had the instructions on your notes that you took Monday? Yeah. Okay. So I'm going to do trace, and I'm going to trace up there. I don't even have to be on the point. Second, calc, which is the second trace key, gives me calc. I'm going to calculate which one. Number 5, intersection. Then all I have to do is press enter, enter, enter 3 times, and it tells me the first answer is intersecting at over 2 and up 1. So I would represent my answer as 2, 1. This is my X answer. This is my Y answer. I like graphing on the calculator. But notice to graph on the calculator, they both had to say what? Y equals, because you have to enter them in the calculator. Yesterday we did substitution. Remember, it's actually a 2-step substitution problem. Okay, 2 steps. So I'm going to say this one says y equals. It could have been one that said x equals. So everything y equals is 2x minus 7. And everywhere y is, I'm going to put right there. Hey, let's go ahead. Everywhere I put a y, I'm going to put 2x minus 7 in its place. So I'm going to keep the 5 and the x, the plus and the 2. Okay, it's just like substituting in a ball game. Y comes out, 2x minus 7 goes in. We just did 2 of these, so this is an example. This is just try to review what we've done the past few days. So I'm going to multiply across and get rid of parentheses, keep the 5x in the front, keep the plus. 2 times 2x is? 4x. 2 times negative 7? Negative 14 equals 4. Now, this is my equals, divides my problem into 2 sides. Like terms, what's 5x plus 4x? 9x. Okay, negative 14 does not have an x, so I need to move it to the other side of the equation. So that would become positive 14. So what's 14 plus 14? 28. 28. So 9x is equal to 28. It doesn't equal 28 because I miscopied a 4 as a 14. So if I add 14, I should be getting what? Should be getting 18, not 28. I put an extra 1 that I did not need to put. If you divide by 9, what's your first answer? What's your first answer? X equals 2. To get your second answer, it's a second substitution step. So I'm going to put negative 2 right here for x. So I'm going to say y equals 2 times x minus 7. And I now know the x value is positive 2. 2 times 2 is 4. 4 minus 7 is negative 3. So I represent my answer in parentheses. The x answer comes first. So it would be 2 comma negative 3. Okay. Let's go ahead and start our notes. Did you find notes on already? It says solving by elimination, and they look like this on the front. Does everybody have that notes? Go. Elimination method is a new method. We've previously learned which 2 methods? We've previously learned what? Graphing and substitution. Graphing and substitution. Write that down. Put your book bag on the floor, please. So what is elimination method? Okay, to eliminate something means I want to get rid of it. And that's the goal. When I see these problems, they're not set up like yesterday's problems. Okay, so with a different setup means a different approach. Okay, so if I eliminate, I'm going to get rid of something. Okay, we're going to get rid of it. Now, my goal is to either get rid of an X or get rid of a Y. All right? So we're going to set up the two equations so that one letter, either the X or the Y, adds to 0. How do you get two numbers to add to 0? Okay, minus that number by itself. Or like, what would I have to add to negative 5 to make it be 0? Add 5, positive 5. What would you have to add to 7 to make 0? Negative 7. So what we want to do is we want to set up a situation to where we add and the numbers add to 0. That means that I need to have one positive and I need to have the same number negative. Does everybody understand that? Okay, one positive, one negative. That way we can add to 0. So it says in order to add to 0, what must you have? Same number. Write this down. Same number, one positive, okay, and one what? Okay, it's important that you kind of know where we're going. Okay, why are we calling it this elimination method? What is the big idea of what we're trying to do? So today, we're going to try to either make the X's become 0 or the Y's become 0. So it's a new approach. The problems will be set up different. So when we eliminate, our goal is to get rid of either an X or a Y, and we have to have the same number, one positive and one negative. All right, got that? Next slide. Now, I have it written in steps. So if you get home, I know some of you have said, I don't understand, I get lost, I forget what to do. Maybe this would help. It says make sure the X's, Y's, and numbers are all arranged the same. In other words, I need them to be lined up. And I'll show you what that looks like in just a second. Make sure at least one letter has a plus and a minus of the same value. So if one's positive 5, I need the other one to say negative 5. If not, we're going to make that happen. Okay? Add the X's, add the Y's, add the numbers. When one letter adds to 0, you'll solve for the one that's left. Substitute the first answer back in. So the last step is the same kind of thing. Okay? It's the same kind of thing. Your last step is going to be same as yesterday. Everybody hear me? Okay, so we're going to eliminate to get the first part. Then you have to substitute the answer back in to get the second part. All right. First things first. This setup looks different from yesterday. It looks different. So I'm going to use a different method. Did you remember yesterday, everything, I had like one equation would say X equals, right? Or one equation would say what? Y equals. And then we'd circle whatever it equaled, and we'd substitute it into the other one. So today, they are not that way. But I want you to notice, do you see your X's are underneath each other? They're lined up. Your Y's are what? Lined up. And your numbers on the other side of the equals are what? Lined up. That was the first step. Make sure X's, Y's, and numbers are arranged the same. I have an X, a Y, and a number. Make sure they are what? Lined up. Do I have that? Sure do. I have that perfectly. Now, what I want to do is, do I have the same number of either letter, positive and negative? Positive 2. Negative 2. All right. I have a positive 2 with Y and a negative 2 with Y. So if I add them, what's going to happen? They're going to be 0 Y. Okay. So we're ready to go. We're already set up. It's a perfect setup for elimination. Y'all ready? Okay. We're going to add the X's. Let's add them up. Straight down the line. What's X and 3X? Add it up. Put that underneath. Got that? Okay. Next thing, add the Y's. What happens when you add the Y's? You get 0 Y. In other words, do you even have anything there? No. You do get 0y, but really and truly, it's like nothing. Then you have a what? Equals are lined up. What's on the other side of the equals? Add them up. Add them up. What do you get? 8. So when I add that and I get 8, did I just eliminate one of my letters?
Yes.
Can I easily solve for the one that's left?
Yes.
How would I solve?
Divide.
Divide by x equals what? 2. Okay. Let's just go back and read. Make sure the x's, y's, and numbers are arranged the same. They were. They were lined up. Make sure at least one letter has a positive and a negative of the same value. I had positive 2 and negative 2 with y. Add the x's, add the y's, and add the numbers. When one letter adds to 0, solve for the value of one left. Now, how do you get the final answer? Is that the same thing we did yesterday?
Yes.
Okay. In this case, I don't have one that's easy. I'd go to whichever one you want. Do you, maybe where the numbers are smaller. Adam, do you like the first one or the second one better? You like the second one? I think the first one has smaller numbers, right? But does it matter? No. You said second one. Okay, we'll go to second one. So we're going to go right here. What do we put it in for? We're going to put it in for the x. So I'm going to keep this. 3 times x minus 2y equals what? 10. We took out the x and we put in what in its place? Put in the 2. You writing these steps? I'll pause and let you write them down. Now I need to solve it and get my y answer. So this is going to be 6 minus 2y equals 10. How do I solve it? I need to get the y by itself. So what happens to 6? I will divide by negative 2, but that probably isn't the first thing I'll do.
Bring the 6 over.
Bring the 6 over first. So it becomes what? If I bring the 6 over, it becomes negative 6, and you're right, I end up with positive 4. That's a negative 2y. I am going to divide as my last step to getting my answer for y. What's positive 4 divided by negative 2? Negative 2. So my answer in parentheses, which one comes first? Should be the x and the, what's my answer? 2, negative 2. And a lot of times elimination's the best. It depends on how this situation's set up. Now, elimination's not always set up perfectly for us. Sometimes we have to do some work to get it there. Are we ready for one? I mean, you ready to move away from one? Okay, I'll pause and let everybody write that down. All right, let's go do number 2. Okay, are they lined up? Yes. M's, N's equals number. M's, N's equals a number. They're lined up. Now, do I have a positive and a negative of the same number with an M or the N? N, right. There's not a number, but it's understood that there's be a what? 1. So I do have a positive 1N and a negative 1N, so I already have it. So let's go straight to the adding them up. Okay, add up the M's, what do you get? Okay, add up the N's, what happens? There's 0. I'm going to cancel them out, they're gone. The only thing about canceling it out is you're still going to need to see the equation, so don't cancel it out to where you can't see it. Remember, we're going to have to substitute back in later. It's on the other side of the equals. Add these up. No, you're adding equations.
10.
On the last one we added. When you add a negative and a positive, that's what, because one's negative, one's positive. When you add, yeah, so you add. Okay.
9.
So I get 9. Everybody knows what we're doing, right? We're adding the M's, and we're adding the what? N's. And we're adding the numbers. What's my first answer? M equals 3. How do I get my second answer? Substitute back into either one. Which one do you want to go in? You want to go into the second. All right, it's fine with me. You can go to either one. Okay, 2 times m, remember I'm going to substitute in, m minus n equals 3. So the answer that goes in here is 3. What's 2 times 3?
2 times 3 is
6 minus n. How do I solve? I'd probably keep n. I'd probably move the 6 over. What happens to 6 if you move it over? It becomes a negative. Okay? That's a negative n is equal to negative 3.
So 3 m equals 2 is not the answer.
Right. You have to have 2 answers. There's an m letter and an n letter, and I'm looking for 2 answers. Just like I did Monday, just like I did Tuesday, or Tuesday was inequalities, but I'm looking for 2 answers. Every example we've done today, we've looked for 2 examples. Shh. So n equals 3. This answer happens to be, and you put them in alphabetical order. The m comes before n in the alphabet. M turns out to be 3. N turns out to be also be 3. M first. 3, 3.
So m is equal to x, n is equal to y.
Yeah. So instead of x and y, they just have to use m and n. You could use x and y. I wouldn't care. Okay. Here we go. Number 3. Let's do number 3. Okay. Are they lined up? Are they lined up? They're lined up. X's, Y's, numbers. X's, Y's, numbers. Okay? This time, do I have a positive and a negative of the same number? That's an 8, and that's negative 2.
Yeah.
That's a 1, and that's a 3. I do not have a positive and negative of the same number. They are lined up, though. So, in this case, we can do something to make it happen. So, here's where you have to make the best, wisest decision. Do I want to do something to make my x's go away or eliminate? Or do I want to do something to make my y's eliminate? And honestly, you can do either one you want. You want to make the y's. Okay, I'm fine with that. If this is a positive 3, what does that need to be? Needs to be negative 3. So what I'm going to do is I'm going to make it happen. So I'm going to come up here to y, and I'm going to multiply that by negative 3. Write that down on your paper. I'm going to make it be the number I know it needs to be, so I'm going to multiply by negative 3. Everybody hear me? Okay. Why did I pick negative 3? Because this one is already positive. Now, you can't just go in and do that to even just one part randomly. If you multiply one part of an equation times negative 3, guess what I have to do to the first part? Guess what I got to do to the last part? Exactly. If you do it to one, you got to do it to all. You still got a problem over here? We seem to have a cell. Okay. So, I need to rewrite the top equation with new numbers. Okay. Got it? You got calculators? Okay. I'm going to rewrite the problem from up here down here underneath. Is everybody okay with that? Okay. Everybody okay with that? Or we could rewrite it beside it. Would you rather rewrite it beside it?
Yeah.
Rewrite it beside it. Okay. Well, then I'm just going to recopy the bottom one because I'm not doing nothing to that. I'm not doing nothing to the bottom equation. But every number on top gets multiplied times negative 3. What's negative 3 times 8x? It's going to be negative 24, and there's an x there. What's negative 3 times y? What's negative 3 times y? Negative 3y. Then it equals. What's negative 3 times 12? Negative 36. Now, have I created a situation where my x's are lined up, my y's are lined up, and my numbers are lined up, and there's at least one number that I have a positive and a negative of the same thing? Yes. Now I can draw my line underneath, and I'm going to add. Okay, add the x's. Add the x's. What do you get when you add negative 24 and negative 2? Negative 26x. What happens when you add the y's?
6y. No. Nothing.
Nothing. I made it eliminate. I made it be 0. What's on get on the other side of the equals? What's negative 36 plus 10? It's negative 26 plus 10. Negative 36 plus 10. Negative 26. So what happens when you divide by the number in front of x? You're going to end up dividing by negative 26. What's negative 26 divided by negative 26? Not 0. What's anything divided by itself? 1. So even though the numbers looked big at first, it actually works out to be a really pretty number. Now, how do I get my second answer? I'm going to substitute back into either one of the original equations. Which one do you want to use? I tend to pick the one with the smaller numbers, but you can go to either one. Which one do you want to go to, Morgan? Top or bottom? Bottom. She says bottom. I'm fine with that. So negative 2 times x, which I'm going to substitute right here for x, okay, plus 3y equals 10. So 1 goes in for x, and x comes out. Everybody see that? So this last step is the same one that we did yesterday. So it is elimination and then a substitution. Negative 2 times 1 is negative 2. What do I need to do to negative 2? Where do I need to move negative 2 to? Where do I need to move it, Lauren? Move it to the other side? What does it become when I move it over here? Positive 2. So I end up with 3y equal to, what's 10 and 2? 12. Divide both sides by 3. What's 12 divided by 3? Your butt is glowing. If I was sitting on my phone and the screen was lit up, it looks like your butt's glowing. Yeah, imagine that. I wouldn't have guessed that you might be using it. Not at all. You just, okay. My answer is 1,4. What do you think of elimination so far? Is it terribly hard? It's not too bad. Today, or this problem was the first time we had to make it work. If it's not working, you got to make it work. Okay. Okay, let's do another one. Let's do one more. Okay, first of all, is it lined up?
Yes.
Got X's, Y's, and numbers. Yes, they're lined up. Okay. I need a positive and a negative of the same number.
Yep, we got one.
Do you think it would be easier to make the X's eliminate or the Y's eliminate? I do have a negative and a positive. Okay.
Well, you could do X's because all you gotta do is add.
Wasn't that X?
Let me ask you a question. 3 will not make a 2, and 2 won't make a 3, will it? So I would have to change both of these to some number they both go into. Like, what can I multiply 3 by, and what can I multiply 2 by to make them be the same number? Could I do that? What's the smallest number that 2 and 3 both go into? 6. Could I multiply this one times 2 and make it a 6? Negative. Could I multiply this times, what would I have to multiply 2 by?
3.
So I'd have to multiply the top by some number and the what? Bottom by some number. But I could make that work. Okay, that's option number 1. That may or may not be the easiest option. Okay, let me ask you a question. Adam, what kind of 5 is that? So what do I need to add to positive 5 to make this one be 0? Negative 5. So what would I have to multiply this one by? No, I already have the positive. What do I need? Need a negative. So what would I have to multiply this one by? Would I have to multiply that one up there by anything? Okay, option number 1. You told me if I multiply this by 2 and this by what? Don't write this down yet. Don't write that down. Y'all hear me? Put pencils down for about 30 seconds. Just look up here. Okay? Okay, just say it. If I make the y's eliminate, I would have to multiply the 3 by 2, right? And I'd get negative 6y. And I would get what? Positive 6y. Everybody good? But that would require multiplying the top by a number and the what? The bottom by a different number. Okay, so that would be option number 1 if I wanted to make the y's eliminate. Okay, now let's talk about another option. Y'all ready?
Yep.
Okay, you said this was positive 5, right? What does this have to be? It needs to be a negative 5. So I would have to multiply this by what? Negative 5.
Huh?
That one's already positive 5. This one would become negative 5. That's option number 2. Does it make sense now what I'm talking about? Which one is easier? Multiplying both equations by a number or multiplying one equation by a number? So, and you could do it either way. Does everybody understand? Okay, let me stop right here. You don't have to write this down. You don't have to. Does everybody understand? Okay, I could make the middle, I could ignore the x's, and I could make the y's eliminate by multiplying the top by a number and the bottom by a different number. Okay, or I could ignore the y's, and I only have to multiply the bottom by 1. So which way do you want to go? And I'm going to let somebody pick it. Which way do we go? Okay. Zach, do you want to make the y's eliminate option number 1, or do you want to make the x's eliminate option number 2? Option 2. Wise choice, my man. You are a wise soul. Why would I do option 2? Because I only have to worry about multiplying one equation by one number instead of 2 equations by 2 different numbers. Does everybody hear that?
Yep.
Okay, so I'm going to erase my options. Okay, and I'm going to erase what I talked about for this one. Okay, everybody agrees. So we're going to make the x's eliminate. If you multiply one thing by negative 5, guess what you have to do to everything else? Everything gets multiplied by negative 5. Write that down. Now you can pick your pencil up and start writing that down. It's about reasoning it out. Why do I pick the numbers I pick? Adam, what you waiting on? You kind of seem like you're... Did you write down the negative 5 all the way across? Okay. Now, do you want me to rewrite them over here? Or do you want me just to rewrite this one underneath? Rewrite it. Okay, I'll rewrite it. Top equation, we're doing nothing to it. Okay. The bottom equation, though, I got to multiply every single part by negative 5. What's negative 5 times x? Negative 5x. What's negative 5 times 2y? What's negative 5 times 2y? It's negative 5 times 2. Negative 10y. What's 3 times negative 5? Negative 15. Now, I'm ready to add them up. I had to reason it out. I had to make sure of which one do I want to eliminate. So this one is the one that's gone. 5 plus negative 5 is 0. X's are gone. Add the y's. Add the y's. Negative 13y is equal to, now what's 2 plus negative 15? Negative 13 again. Divide by negative 13. Y equals what? You're right, it's 1. Anything divided by itself is 1. Anything divided by itself is 1. Okay, I can go to which equation do I have to go to? Either one of the original, right? Do you want to go to the top one or the original bottom one? Top one? He said he wants to go to the top one. Is that okay with you guys? I'm going to go and I'm going to put it in place of y. So 5 and x minus 3 times what used to be y equals 2. 1 goes in there. 5x minus 3 times 1 is 3. What do I do? I need to add 3. To take 3 to the other side becomes positive 3. So I get 5x is equal to 5. Divide by 5. Yeah, I think that's just that they picked easy number for examples. But none of ours turned out to be too bad. Elimination will end up being the one that you'll go to the most.
I thought that was like sign or something.
We're going to skip to 6 and 7. Everybody good?
Yes, ma'am.
Let's go to 6. Shh. Let's go to 6. I see a problem with 6. What's the first thing you notice?
They're all positive.
That's true. I see positives, but are my X's, Y's, and numbers all lined up?
Oh, they're positive.
No. I got X's and Y's, and on the other side of the equals, I got my number. I'm going to have to move something. Something here needs to come to this side. What needs to come over here? I need to bring the 4. The Y needs to come over here, right?
Wait. So this is 3x equals in the top.
That's right. See, this one says 9x. It says an X term plus a Y term, then equals, then a number. They have to all line up and be the same way. This one says X equals, and then Y is on the other side. So I need to bring Y to this side and rewrite it. Okay, so I'm going to have 3x. When that negative 4y comes over here, it becomes positive 4y equals negative 2. First thing I had to do, I had to move before. So that's the first thing. Okay, I'm going to go ahead and finish this. I'm going to rewrite it fresh so that nobody has any confusion. I'm going to rewrite it fresh. So after I move that term, it's not one to erase. Okay, I'm going to recopy 9x plus 12y equals 3. Now before I do that, does anybody have an idea which one we might want to eliminate? You got 9x and 3x. You got 12y and 4y. Does it matter which one you eliminate? No. Which one do you like to eliminate best? Noah, do you like x's or y's? Y's. Okay, Noah said he wants y's. Okay, here Noah, this is positive 12. What does this one need to be? What do you add to positive 12 to make it be 0? Negative 12. What do I need to multiply this by to make it be negative 12? Not just 3. That's already positive. This one needs to become, so I need it to be a negative and 3. If you multiply everything on the bottom by negative 3, first one has to be multiplied by negative 3, and the last one needs to be multiplied by what? Negative 3. Okay, so now I'm going to rewrite my equation. What's negative 3 times 3x? Negative 9x, right? 3 times 3 is 9. What's negative 3 times 4? Negative 12y. What's negative 2 times negative 3? Positive 6. What just happened? Okay. Okay, do the y's eliminate? Yes. What's left? It turns out when I got y's to eliminate, the x's also eliminated. What's left over here? You got no x's plus no y's. How much is that? What's none of these plus none of these? So what do you got left over here? Nothing but you got 0. You got nothing. What do you have on the other side? What's 3 and 6? Maybe you got to add those. You get 9. Is that a true statement or a false statement? Is 0 ever equal to 9? Ooh, I wish I could convince the bank of that, right? Oh, you just think my account says 0. Really, I got 9 times more than that. Right? Really, I got $9 in there. Okay? This is a what? False statement. 0 does not equal 9. So what does that mean? That means the lines must be what? Those two lines are going to end up being what? Parallel to each other. So that's what it looks like with elimination. You end up having everything canceled where there's 0 equal to something that's not true. Everybody good with that? Okay. If that happens, where you get 0. Okay, let's do 7. 7 will be our last example. Okay, first of all, are the x's lined up? The y's lined up? And across the equals are the numbers lined up. So I don't have to move anything first. Everything's lined up. What do you want to eliminate? X's or y's?
Wow.
Okay. Okay, this is positive 20, and that is already negative 4. So what would I have to multiply negative 4 by to make it be a negative 20? Remember, what do you add to positive 20? You need I need to multiply by 5. So if I multiply that one by 5, I have to multiply what? What you do to one part of an equation, you must do the same thing to all parts of the equation. So I'm going to rewrite it. 5 times negative 2x is negative 10x. What's 5 times negative 4y?
Negative 20.
Negative 20 with a y. What's 2 times 5?
10.
Am I doing anything to the bottom equation? Uh-oh. Something weird happens here.
No solution.
Nope.
Oh, well.
Infinite solutions.
Oh, yeah, because they're all the same.
This one gives me what? Nothing. Plus, this one gives me nothing. And on the equals, this one gives me, does 0 equal 0? Is that true or false statement? That's a true statement. Right? So really and truly, those two lines must actually be the same one. So every answer on the line, so this one has what? Infinite. Okay. They must be the same line.